respect to malware, and since we were just talking about developing exploits, something that I have been curious about is there's a lot of stuff that has come into the market with healthcare devices, right? Healthcare or medical devices. We had Windows and Linux earlier with respect to their, base OS. Now we also have Android, iOS based platforms where these are there. But I think majority of the operating systems that these devices would generally be working on would be Windows or would be Linux based. Now, from my own experience of doing it, like I was telling you, and creating payloads, it would be very different. So if we are having a same exploit across Windows and Linux, the exploit itself will need to be crafted differently for Windows and differently for Linux. And even for different versions of Windows, right, you will have to have different exploit because the memory structure is slightly different in different versions of Windows itself. But with Linux, it would be quite different. What I was curious to know is, does that apply to the OS that healthcare devices are based on? Like the healthcare device forensics itself has this gap as well. Do you see that? And how do security teams, who will also need to know, right, the structure of malware, how it works, and the OS itself, how do the security teams navigate this gap where the documentation for Linux might be much lesser as compared to that for Windows?
That's a very good question. So probably we love decoding cyber attacks, okay, but the moment we see a cyber attack on a Linux server or like a custom OS, and it's absolutely a big nightmare for us, The reason being is some of these advanced attacks, right? If you see the trend in the healthcare industry, most of the healthcare devices will never connect to the internet. But however, there are a lot of R&D activities that usually happens inside the healthcare industry. And some of the healthcare industry devices, let's say, if they even talk to the internet, let's take IoT for an example, IoT-based devices. Now, we've come to a level where these scans and all can be IoT devices, remote-based devices, and they heavily don't operate on Windows. They operate on Linux. Let's say some of these devices get attacked. It's a huge call to perform a forensic activity. Now, you neatly bifurcate it, right? I mean, when you ask this question, you neatly mention that Windows versus Linux. I mean, Windows has always been documented, and Windows always has the ability that, the basic structure of looking into a process's memory. You can always leverage one process's memory with another process. You can use the APIs to play around freely with a lot of things. That's the reason why writing Windows malware is also very easy, because you like it's I usually refer Windows APIs as Master Chef, a pantry, because you just need to know the recipe and all the ingredients are there for you. You just need to go and take it and come. But Linux is a very different ballgame, and especially in healthcare, it's you will never get a profile. So when you do memory forensics, right, we call something as a profile. Now, memory forensics, if you see from like a 50,000 foot view, if you probably go very closer to it, it's scary, okay? But if you see from a very 50,000 feet view, I mean, I'm just going to break a lot of bubble here, okay, here. Memory forensics, it's just nothing but walking through the memory or just walking through the data structure of Linux, that's all. There are a lot of magic numbers, which we usually call, right, in files. Now, let's say 5D4 says probably talks about exe. If you see the MZ header, you can see it's exe. Similarly, there are magic numbers, which we usually call as KDBG. Okay. Using the KDBG values, you can see in the memory saying that, hey, this serial number exactly matches a Windows XP, or it's an SP1, SP2, it's documented. But for Linux, it's totally different. The mapping, the kernel, the memory structure all looks different. You cannot do the profiling just like that. So there is a way that you have to create a profiling. Now there comes the huge pain point here, okay? Now in usually happens in Windows is you can just take the dump of the memory, save it as a raw format, or save it as a mem format, and then you play around with it. Now the 101 principles of digital forensics is never make the infected device connect to the internet, or don't do any transaction inside it. But here, when it comes to the Linux part of things, you'll have to go to the machine and take a dump of the memory, and you'll have to do an X set of things to get the profile version of it, build it. So when you build when you build something on that Linux, it's probably against the chain of custody rules in forensics.
Yeah.
And especially when you come to a custom operating system, which is being used in most of the healthcare industries and supply chain industries and wind and power industries, they don't use the the Linux version directly. They write a wrapper on top of it, they harden it, they do a tons of. How do you know what profile it is? How can you build a profile out of it? And then there are no plugins for you to do the investigation. Not much is there.